Hey friends, you're in the right place. So either you're absent today because you're sick or you're on vacation, but you're not here with us. So what you're going to do is watch this. You got to the right spot. Check in with me. I'm going to show you what went on in class today. I'm going to show you what we did for homework. So we came in, we picked our cards, we played our bells, and then we put this up. And we said, what's going on here? What different measurements are changing in this video? We showed this video. And then we gave the kids a minute to think on their own. And then we said, okay, think, pair, share. And then we wanted the groups to share what they thought the variables were. And then we asked Michigan and Ohio State and Michigan State and the different tables. And this is what they came up with. They said the variables that changed were the time. Did you see that clock up in the corner? And then they said the height of the person. So how high the person was up in the air. Okay, so that's what we did first. And then after that, we looked at this and we said, sketch this relationship. The height of the person's waist above the ground and how many seconds are going through. So we got like little pieces of paper. We said, okay, what's the height of his waist and how long, what's the time frame in number of seconds? So I said, well, it looks like about at 0 seconds, he's about, what do you say, about 3 feet. His hips are at 3 feet. And then he's walking up to about 5 seconds. At about 5 seconds, it looks like he's, I'm just guessing, 1, 2, 2, 2, 1, 2, 3, 4, 5, 6, 7, 12, just a guess. And then he stays at 12 until 6 seconds. And then at 7 seconds, he goes down to about 10. I'm just guessing. Now, and I told the kids you don't have to be perfect on these, right? We're just trying to get a feel for the general shape of this. So then we came here. And he stayed till about 12 seconds. And then at 12, he went down to 13. So that was down from 7 seconds. He went down. And then at the very end, 14, he stood up. So he put on a foot or two. So then the next question is, can you graph this? Sure. So we went like this. We said, well, at 0, he was about 3 feet. And that lasted until about, then he started going up until 5 feet. And then he's up to about 12, we were guessing. And then at 6, he was about 12. And then at 7, he went down to about 10. And then we went down to here. And then he stayed there till about 12. And then he went down really quick. He went down the slide. And then he paused. And then he kind of dipped up a little bit. Something like that. So that's what the kids did, and we brainstormed their solutions, and the kids came up to the board. They put their problems up. All right. So next, we took a look at what CPM came up with, or his height based on time. That looks like ours. Right? So then what we did next is we said, we'll have to graph this relationship. What's happening? How much water is in the bowl in liters? And I see there's water in the bowl and I see a trickle over time. So I'm going to say, well, let's say we're starting with, let's say there's a liter of water in here. 7 seconds, the water turns on. 11. There's just a stream again. So I kind of thought like something like this. From 0 to 7, it went like this. And then it kind of like increased more until 11. And then it kind of leveled off again until 15. How does that look? So we kind of came up with something like that for that graph. Next, we said how many eggs are in the carton over time. So it was eggs on the y-axis, time on the x-axis. And at 0, we're starting with 5 eggs. So we should probably start right there. Let's see what happens here. All right, at 1 second, we went down to 4. 5 seconds, we went down to 3. Oh, and then just way later, we went, just a short time past that, we went down to 2. And that looks like about 11 seconds, we went down to 1. 13 seconds, we went down to 0. How's that? Next one. How far is the camera? How far is he away from the camera? I'm going to write some notes on this one. So let's say he starts, what is he, 3 feet from the camera? And over here, he's like what? 9 feet from the camera? I'm just going to guess. Do we have to be perfect on these? No. So I'm going to say at 0, he's about 3 feet from the camera. And I'm going to kind of time out when he's at the furthest point. So at 1, I would say he's about 9. And then at 3, he's back to 0. About 5, he's back to 9. About 6, he's back to 0. About 8, he's back to 9. About 10, he's back to 0. And 11, he's back to 9. And then he sits. 12, he's at 9. And then 13, 14, 15, he starts walking away. All right. So that's what I kind of wrote down here. Let's take a look at this. So I said 0. He's about 3 feet away. So he's about 3 feet away. And then at about 1 second away, he's at 9. So I think he went like this. Whoops. That's okay. And then about 3 seconds, he's back to 0. He's about 3 feet away again. And then about 5 seconds, he's back to 9. Mr. Johnson, you're making a mess. That's okay. At 6 seconds, he's back to 3 feet away. And then at 8 seconds, he's back to 9 again. In about 10 seconds, he's back to 0 again. And then 11 seconds, he's back to 9 again. And then he kind of stayed there at 12 seconds. And then 13, 14, 15, he started walking away. Whoops. How do we do that there? Something like that. Wait a minute. I'm going to redo this one. It's kind of tough to draw. All right. 0 seconds, he's 3. I would say he's about 3 away. Then at 1 second, he's 9 away. I'm doing the same thing. And then 3, he's back to 0. And then at 5, he's at 9. And then 6, he's at 0. And then 8, it looks like 9 again. Looks a little better. 10, he's back to 0. And then 11, back to 9. And then 12, he stayed. And then 13, 14, 15, he started, whoops, walking away. All right, I'm going to stop while I'm ahead with that one. And what do we do next? Oh, this one's interesting. What's the distance from the center of the carousel? So when he's going, does he ever change his distance from the center? It always looks like he's the same from the center. But he stops at 12, and then he walks away. All right, so I'm thinking something like this. I'm going to say 3 feet. He doesn't change, he doesn't change, he doesn't change. And then he stops here, and then he starts walking away. That's my guess. Okay. So let's see how we did. Water in the bowl. We predicted something like this. Let's go back to what we predicted. We predicted this. This is what we found out when we watched. Okay. Eggs. We predicted something like this. This is what we came up with. Let me check. The distance from the camera. The distance from the camera. This is what we came up with. This is what CPM came up with. Now he's walking away. Beautiful. And then the last one, I believe, is the distance from the center. And we thought that this one didn't change. So we said it's about the same, and then he walks away. This is what they came up with. Cool. Then the next thing we did is we said, let's pick one of these and let's change what we're looking for. So we said maybe instead of how many eggs are left, how many spaces are there over time? Or how much space is in the bowl instead of how much water is in the bowl. So we came up with our own variables, and different classes came up with their own. And then we shared those and we made a graph of those. Cool. So it was fun. It was a fun assignment. Then I showed the kids their homework, and this is what I'm showing you now. So if you have your ebook, beautiful. If you don't remember how to get into your ebook, all you have to do is go to CPM Math. Right? Look for the one that says CPM Math in every class. Click on that one. Now remember, you don't need to have your username and password. All you need to do is log on to your, just find the Google G and then click on that. So I'm already logged in, so mine's not going to go to that. But you just click here. It'll tell you to log in. You click on log in, and then you just go to your Google G. And then when you go to Google G, it'll get you in your ebook. Click on your ebook. You're in course 3. So we click there. And the lesson we did today was 1.1.1. Chapter 1, day 1, lesson 1, day 1, right there. We just did the graphing. What stories can a graph tell? You did that with me just now. And now we're going down into homework. Here's your homework. You have questions 1, 4, 1, 5, 1, 6, 1, 7. And it says this: diamond problems. Finding and using a pattern is an important problem-solving skill that you'll use in algebra. The patterns in diamond problem will be used later in the course. Maybe you've done these before, but here are the numbers 5, 2, 7, and 10. How do they relate to each other? 2, 3, 5, and 6. How do they relate to each other? -1, -4, -5, positive 4. How do they relate together? And then this one is just number, question mark, question mark. Like, what's the pattern? So then these are what you have to turn into me. Copy the diamond problem below. If you use the same pattern as this, and you started with 3 and 4, what number would be here? What number there? If you started with -2, -3, what number? If you finished with 7 and 12, what are the starting numbers? If you knew one starting number and one finishing number, what's the other starting number? What's the other finishing number? And if you have 2 finishing numbers, what are the starting numbers? If you are lost, you can cry or you can check your homework help. So homework help will give you some hints and get you started in that right direction. So I clicked on homework help here, and it says copy the problems, then use the pattern. And then it says I need a hint, so click on hint. It says, what do you do to each of the numbers to get to the question mark numbers? If you start with these, how do you get to these? And if you still need help, it'll give you the answer, and we'll explain like how they got to that answer. Okay? Now let's go back to problem 1.5. 1.5 looks like this. Draw and shade a figure that's 100%. Label your figure 100%. Describe the figure in words. If you need hints, here we go. Hint says if you have 100% of one pie, how many pies do you have? Then it says draw and shade figures that represent 50%, 25%, and 150%. If you need hints here, write another fraction that's equivalent to 4/5, 4 out of 5. Draw diagrams to show that they're equal. Then find the equivalent decimals for both this. Check your hints here. Draw and shade a figure that represents 1/3. How can this figure be represented with a number? Hints are here. Describe what the diagram at right represents using words and numbers. Hints are here. Let's go back. That's 1.5. 1.6 is here. Susan's apartment is at the right. All the rooms are rectangular. Find the areas described below. All measurement are in feet. Find the area of the room. Of her living room. What's the area of the living room? I don't remember how to find out area. Hint. Area is the total square units inside a shape. So if we have 15 this way and 18 this way, still need more help. Click here. The area of a rectangle is base multiplied by height. 15, 18. I still need more help. Find the area of her entire apartment. How much larger is the bedroom than the living room? What's the perimeter walking around the kitchen? Click here for hints. And then your last problem is 1.7. The following 3 graphs describe 2 cars, A and B. Decide which of the following statements are true or false and explain your reasoning. The new car is more expensive. So here's a car of age. This is the new car. This is an older car. This is the cost. So this is a less expensive car. This is a more expensive car. This is the cruising speed, how fast car B is. This is how fast car A is. This is the size, small to large, car B and car A. This is the passenger capacity, how many people can sit in there. Car B, lower, car A, higher. This is a range. This is how far this car can go. A gallon of gas. This is car B, lower. This is car A, higher. So use your hints, use your clues to figure this out. That was Monday, September 11th. Okay, Monday, September 11th. So I hope you're feeling well. I hope I see you tomorrow. And if not, get on Google Classroom, check in with me, and get on eBooks, and I'll help you out. All right. Have a beautiful day.